All right, this is a little breakdown for you. This is a client project I can share, and we have this nice effect where the blue flames grow and then they kind of shrink. This is a feature of the grill we're showing off here. And another cool thing about this is you could see there's this random flickering of the flame itself, which is really nice. Now, this is also incredibly efficient in Blender. We're not using any video files or anything like that. All we're using is a single image of a blue flame, and then we have two node networks that are making the magic happen. One is the shader node network, where I can grow and shrink the influence of the flame, and number two is the geometry node network, where I'm controlling the flickering of the flames. So let me go ahead and open up this Blender file and show you both of those right now. So first of all we have is an image imported as planes into Blender. It's just a blue flame image. And right off the bat, I'm driving things like the base color, emission color, and the emission strength with this image. So the image itself is just a black and white image of a flame, as you could see right there. So first thing we're doing is we're just driving the base color, the color of the emission, and the emission strength with that image. We are also driving the alpha value with that image. So we have that image coming into alpha. I could just plug it in just to show you. I could just plug that image straight into alpha, and you could see that's how that's working. Now, I don't have it straight into alpha. I have it through a mix node. And why do I have it through a mix node? Well, I'm driving this mix node with another node setup called gradient texture. And the reason for that is, as you could see in my animation, let me find a good angle here, the influence of the flame grows and shrinks. And what it's actually growing and shrinking from is this one empty. So I added an empty to the scene and I called it flame fall off. So just add an empty, I called it flame fall off, and then I'm scaling this empty. I'm animating the scale of this empty in the scene. For the actual texture now, let's go back to our flame here. Let's see, I think this one is redundant. Let me just check. No, that one. Okay. Okay, let me show you what's going on here. So I have a gradient texture. The coordinates, the mapping of that gradient texture, if you just grab the gradient texture with Node Wrangler, which is an add-on that comes with Blender, if you just hit Control-T, it'll add a mapping and a texture coordinate node. That's very important to have to apply any kind of texture to a surface. In this case, instead of using the UVs, instead of using generated textures or anything like that, I'm using an object to drive this texture. And for the object, I've identified flame fall off. Now, what this does is basically if I grab that empty, where is it? Right here. You could see wherever I move that empty is now controlling the alpha of this flame texture because I have that going into a gradient texture. So it's telling me to make a gradient where this object is, flame fall off, and I've set it to a spherical gradient, which basically means it'll emit from the origin point of whatever that object is. So in the empty, let's pretend my phone is the empty here. The origin point is here. When it's set to spherical, it's growing a gradient from that origin point in the object. So we have kind of this sphere of fall off in the scene now, which is our empty. And that's going through some map range nodes. Now, why do we use map range? Well, let me just mute these. Mapping a range is kind of like you have from 0 to 1 by default. Mapping a range is playing with those numbers. So for example, let me unmute these. Right now, this first one, it used to go from 0 to 1, and that correlated with from 0 to 1. Now it's going from 0 to 5, and that's the new 0 to 1. And also, okay, sorry, there's a lot going on in this one. So the important thing to think about is minimum, or rather from and to. So you're taking a range of 0 to 1 and you're changing it to a range of 0 to 1. So for example, if I have 0 to 1 in the from and 0 to 1 in the to, then this is unchanged. Nothing happened. It's taking what was 0 to 1 and it kept it as 0 to 1. However, what I told it to do first is I said go from 0 to 1 and change that to 1, not 10, 1 to 0. So that immediately inverts what we had. From 0 to 1, now it's from 1 to 0. I'm also telling it go from 0 to 1 and changing that from 0 to 5. Why am I doing these things? Well, drop down your map range node and start playing with these values to see what you can get. The reason I did this one, for example, is I had a really harsh line fall off as this empty grew. So it was very harsh. It was like anything within the empty was on and anything immediately outside of it was immediately off. So I grew the from range. Instead of from 0 to 1, I went from 0 to 5. And that was just to kind of soften that fall off. So if I went from 0 to 50, for example, you could see there's a more of a gradual gradient. Okay, so that was my first map range node. You can have as many map range nodes as you want. You can continue to alter values. The second one goes from 0 to 1 to 0 to 1, but on the from minimum, I changed it to 0.881. So if I set this back to 0, you could see I'm just clamping down to make that more of an intense fall off. Hopefully that makes sense. Map range, it'll take a second to wrap your mind around, but as soon as you get it, map range has become absolutely my most used node in shader node networks. It's really important to understand. So we have that gradient in 3D space. It's a spherical fall off. We're manipulating the range of that gradient to clamp down on our values just like we want them. And that is going into the factor on a mixed color node. So before we went into this mixed color, it was just the image using as the alpha. After we go into this mixed color, we're using the factor of the gradient to change the second input, the B slot, to black. We just set this to a total black material. If this was set to white, you can see what the alpha would do there. Everything would be, actually I could show you in the shader. Everything that's set to white outside of the gradient fall off would just be completely non-transparent. It would have an alpha value of 1. But we can set this to black or 0, and now everything outside our gradient fall off is 0. Simple concept. Once you understand how to use this, it's very powerful. You can change and control the opacity of one texture based on the location of an empty or the proximity to another object. It's just really powerful. It may take a second. Rewatch this section. Hopefully I've explained that well. But now what we could do is we could take this empty, and as I scale it up and down, you can see it's controlling the influence of the flame, which is really important for this setup because this particular client wants to show that we can have all the flames active, or we can just use a section of this grill if you don't need as much heat. So that's what the client wants to show, and we can do that with the power of a shader node network. So that's step number 1, is the actual shader node network to control the fall off of the flame intensity. If you're still with me, let's go to the geometry node network. So looking at our grill here, we have a little nozzle here where each of the flames comes out. The first thing I had to do was I had to go and I had to create a piece of geometry where I could actually place, let's see here. Yeah, okay, I'll go to X-ray mode. I had to place a vertice at the top of each nozzle where I know I want a flame to come out. And the reason for that is I knew I was going to instance objects on geometry, on points. So I had to have a point everywhere where I want a flame to come out. So once I created that, just normal, I added a geometry, or I added a vertex to the scene, and then I duplicated it around until I got a point at each opening there. Once I have that, let's go into the geometry node network here. And let me show you, let me get some things out of the way so we can see what we're doing. Let me show you what we have going on here. So we start with just a geometry input. This is just our points in 3D space. That's our geometry input. From there, I'm dropping down an instance on points because I want to put an instance of something on every point. So what are the points? Well, it's our geometry. What are we instancing? That's where another part of the equation comes in. I drop down an object info. You could just search for object. And an object info node lets you grab any object from the scene. If I wanted to instance a collection, I could grab a collection info. Okay, so I grabbed an object info and it's asking me, what object are you trying to get here? And I told it I'm using the flame object, which is just that single image plane that we looked at in the shader network. So I said, get the flame object and use that as my instance. Okay, when I brought it in, it looked something like this. The problem with this is they're not rotated in the right way. So to fix that, I just drop down a transform geometry because I'm transforming the rotation of those instances. And I'm just going negative 90 degrees on Y, 90 degrees on Z, just until I got it upright to where I want it. So that's where the transform geometry comes in. And at this point, we would have all of our little flames instance on the points, on the geometry, and it looks great. If we look at it rendered view, that's working really well. However, what if we want this little flicker motion? Well, that's where we have this last little setup. So in geometry nodes, there's a really handy node called random value. When you first get the random value node, it doesn't know what kind of a value you're working with. There are options for different types of numbers in Blender. There's floats, integers, vectors, or booleans. Basically, what we're looking for, because we can scale in 3 directions, X, Y, and Z, we are looking for a vector random value. A vector is basically a collection of 3 numbers, X, Y, Z, red, green, blue. These are some examples of vectors in Blender that are common. But a vector is just any 3 values that are collected into one property here. So I have my random value, I have it set to vector, and then let me just get rid of this for now. We'll talk about that in a second. If I go from the value to the scale, let's go to object mode so you can really see what's going on. We have a minimum and a maximum again. So for example, if I had the minimum set to 0, that's saying, hey, for all of these little planes, you are allowed to have a minimum value of 0. So in the case of this one here, that's close to 0. That's almost non-existent. That's almost all the way gone. So I don't want a minimum value of 0. I want a minimum value of 1. I at least want, as a baseline, each flame to be 1 value in X, Y, and Z, so that it's not no flames are disappearing. Similarly, we have a maximum value. This is saying, okay, how big can these flames get? And it's going to be random per instance because we have this random value. So for example, if I increase the scale this way, you could see they have the possibility to get very large on that x-axis. Same with y and z. I'm really not, changing the scale of these very much. It's just little flickers. So I have it set to 1.1 on x and y. And there's a little bit more change on Z, the height of these flames. So I have that set to 1.3. So now you can see we do have some random scaling happening. But the problem is, if we play through our timeline, that's not random per frame. It's just kind of one static random value. And they're all different scales, but they're not flickering. To get the flickering, we add the last piece of this puzzle, which is the scene time. Now for this, you can use seconds or frames. I used frames and I just simply plug that into the seed. The seed is a way to randomize the effect of the node network. And now, as you could see, that's just randomizing every frame in our animation, which is exactly what we want. We get this nice little flickering that's very flame-like. You could also use something like seconds, but that's just going to change every second in your animation, which we don't want. We want to go by frames and change that up every single frame. If I were to increase this value, it would be more sporadic on the Z-axis because the maximum possibility of randomness on Z would be greater. So that is the whole geometry node setup. Very simple. That's also the shader node network setup. Once you can grasp that idea of the gradient fall off using the object of the empty, then that should make sense. So yeah, there you have it. Let's take a look at the animation one last time over here. You can see the flames are flickering. You can see there's a nice fall off limiting effect that shrinks down where the flames are coming out of. And yeah, hopefully that's been helpful. There are lots of ways you could apply these concepts that we've just covered. So feel free to share with me once you apply any of this. I'm not super into geometry nodes, but I know just enough to be able to work through basic stuff like this that really would be incredibly difficult with any other method. And the nice thing about this is it's nice and efficient. It renders very quickly. It's using instances, and it's only using a single image for all of these flames, which is really nice that we can get away with that. So anyway, thanks for checking this out. Hopefully it's been helpful, and I'll see you on the next one.